This is the practice test I'm going to be going over here. Either watch the whole video or just fast forward to the parts that you actually need help with. So over here we have a function graph, the piecewise function. We can see it's got looks like a quadratic piece here, a linear piece, a constant piece, and maybe a square root function right here. So first it's asking us to find the zeros. Remember, the zeros are the x-intercepts here, actually the real zeros. So there's an x-intercept here and an x-intercept here, -3 and -1, which is the answer. Now domain are just the set of all x values we're using. So if we go from over at -4 all the way to 5, we can see that's the domain. Now we use a bracket at -4 because it's a solid circle actually including -4 in the domain. Well, 5, it approaches 5, but 5 itself is not included, so we use a parenthesis. For the range, you can see it starts at -3 and then goes all the way up till 2. You can see there's no breaks in it. And even though there's an open circle here, we can see over in the middle and here that we're using those y values. So it's -3 to -2. Now, for the next section here, these are intervals that y is either increasing, decreasing, or constant, and we describe that in terms of the x values. So when it says where is it increasing, it's actually asking where are the y values getting bigger. So you can see it's all the way from here to here, and then again from here to here. So those are two intervals that it's increasing over, from -4 until looks like -2, and then from -1 until 1. And you can see that we always use parentheses on here because they're intervals that these are increasing, decreasing, or constant on. So we're not including the points. If we were trying to find where it's increasing at a point, we'd be talking about calculus. So the next one would be a decreasing interval, where the y's decrease. And you can see that the y values decrease from here to here, and also from here to here. So now we're going to describe it in terms of the x values. So from -2 to -1 it decreases, and then again from 3 to 5. And lastly, we're going to look at where is it constant, where are the y values not changing, and you can see that there's a horizontal line here, a constant function, and we can see that comes from x equals 1 to 3, and again, we don't use brackets because it's just between where it's constant, not at the points. This next question asks us, for what values of x is f of x greater than 0? Remember that f of x is the same as y, so they're asking us, for what values of x are the y values greater than 0? Now this answer is actually not correct, and I'll explain why. You can see that from -3 until -1, the y values are clearly above 0. But at -1 it equals 0, and then again after -1 you can see that all the y values will be above 0. So the problem with this answer here is that at -1 it actually equals 0, and this is asking us where is it greater than 0. So yes, it's going to start at -3 being greater than 0, but when it gets to -1 it's equal to 0, so we need to skip over that. So this is actually the correct answer to this question. Now if I come over here and change this to greater than or equal to, this answer is almost correct. The only thing we'd have to change is at -3 it actually equals 0, so this would become a bracket, and then we'd be okay with the -1 because at -1 it also equals 0. Next question asks, for what value of x does f of x equals 1? Again, that's y, and it's asking us, when y is 1, what is the x value? So we can see when y is 1 right here, we can see that the corresponding x value is 0. Next part asks, for what values does f of x have a relative max? Remember, relative maxes are points, and you can see one right here, where all the points around it are less than that point. And again, we're talking about the y values. So you can see at -2, there is a relative maximum. Again, it's described in terms of the x value. Now you might be thinking, what about this point right here? Isn't that a relative max? Well, the reason why we don't consider that a relative max is you can see on the right side, it's not lower, it's the same. So right there, it's not actually a relative max. Now over right here, you can see you have a relative min because all the points around it have actually higher y values on it, so it's a valley, and that makes it a relative min. Over here you might think it's a relative min, but the reason why it's not is, first of all, it's an open circle, so we're not including it, is the main reason, but also because we don't have this side of the graph, so it's not sloping down on this side as well. So the next question asks us to find the zeros. Remember, the zeros are the x values that make the y values equal 0. So plug in 0 for f of x, replace it. The easiest way to solve this is to solve by factoring. So you factor this polynomial. You might need to brush up on that. Go check out a factoring video. Factors into this, set each factor equal to 0 individually and solve. Then you get x equals 4/3 and y equals -2. Now this is a polynomial function. So to find the y-intercept, technically you plug in 0 for x. But in every polynomial function, the constant term is always the y-intercept. So that's an important little shortcut to know there. Because if you plug in 0, this is the only number that would survive. So let's scroll down a little bit. These next problems, you want to find the domain algebraically. Remember that domain are the x values that we're going to be using for a function. So really we just got to think about, are there any x values that if we plug in would cause a mathematical problem? Now on A, you can see this is a polynomial function. We're never going to have any problems plugging in x values to a polynomial function. So the domain is -infinity to infinity. So every polynomial function, once you notice it's a polynomial function, you know its domain's -infinity to infinity. Now B here has a square root. So what could happen mathematically that we're not allowed to have in the real number system with the square root if we take the square root of a negative? So we know we have to keep the inside of the radical positive. So we're going to set it greater than or equal to 0 and solve. And now we know that we can only use x values that are bigger than or equal to 6, otherwise you would get an imaginary number. And here's the answer in interval notation. On C, because we have a variable in the denominator, it might be possible for the denominator to equal 0, and you're not allowed to divide by 0. So what we would do is we try to set the denominator equal to 0, but when you try to solve this one, you'd subtract 9 from both sides. You'd end up taking the square root of a negative, which will give you two imaginary answers. And since we graph in the real plane, we don't use imaginary numbers, this actually has no restriction to it, and its domain is -infinity to infinity. And if we think about it logically, x squared could never come out to be negative, and it would have to be -9 in order for the denominator to become 0, and it'll never get there because we're squaring, so it's impossible to make the denominator 0, therefore there's no restrictions. On this next problem here, we're going to take the denominator and set it equal to 0 again, because we can't have the denominator equal to 0. There's a few different ways you can solve this. I'm going to use the square root method, but you could solve it by factoring. Add 9 to both sides, and then take the square root. You get x equals plus or minus 3. So in reality, x can't be those numbers, because then the denominator would equal 0. Here's some work down here for that. So this just means skip over -3 and 3. They're excluded from the domain. Let's talk about some piecewise functions here. We wanted to write the equation for this piecewise function. So the first thing we should see is that it's 3 different pieces. So we'll set up 3 different domains. We use this first piece for x values that are less than -1. We will use the middle piece for x values from -1 to 1. And we will use the last piece, the constant function, for x values from 1 to 4. So that's the first thing I would set up. The next thing I would do is try to figure out the functions themselves. Now I'm actually going to do this middle piece first because it's a little easier than this first piece. So this is a line, it's a linear equation, we can see that. So all I really need is the slope and the y-intercept. I can pick out the slope, I can see it's a -1, so I knew it was -1x here. And then because it crosses the y-axis, I can see that the y-intercept's 1, and I put that here. This next function over here is just the constant function, so we just have to check out its y value, which is -1, and that's the function. For this piece over here, the first thing you want to do is figure out the slope. Now the biggest mistake people make on this is that they try to get the slope and they'll go backwards and they'll think that the slope is negative, when in fact, remember, you have to go up, you're going to go up and right, which is positive. So up 3, right 1, the slope's 3. Now there's a couple ways to get the y-intercept on this one. You could just keep the slope going, up 3, right 1, and see the y-intercepts 2. Or you could have done something like put this into transformational form with this point right here. So I knew the slope was 3, and I can see this just shifted left 1, down 1. So I could do 3 times x plus 1 minus 1, and if I simplify that, that'll take me right to here. So that's another way to do it. Down here, number 4, you are just graphing a piecewise function. Use table of values for these. It's probably the easiest way to do it, or you can kind of think about the shifts as well. You can actually do it that way. Remember to always plug in the boundary number. Like, you might not think you need to plug in 1 on this because it's not equal to. We're always going to plug in that boundary number even if it's not equal to, and we're just going to represent it with an open circle. You can see that's done right here. because it's all the way up to but not including. So that's usually the biggest mistake people make on these. Same thing on number 5. We have a linear function. We have a We have a linear function. We have a constant function, and we have a quadratic function. You can see that graph there.